Welcome to what is hopefully going to be the last installment of Physics at the Beach. Today's video is going to be about how to determine the direction of a vector. Vector quantities have both size and direction. You'll be learning in class this week how to use a ruler and a protractor to determine how to draw the vectors according to a scale model. But if we have issues with how to do the directions, then we're not going to know what to do with the protractor. So this whole video accompanies a practice worksheet for you to do for your first, or maybe it's a second, I think it's your second virtual day. It's on Schoology. So first of all, you have to know that even though we're not really worried about true compass settings, what we are worried about is that we recognize that up is north and down is south, and to the left is west, and to the right is east. And this is what we're going to use to determine in which direction vectors are going to be found in the four quadrants of our plane. So what we need to understand is how we describe them. And the way we describe them is we use an angle measurement. So if this is the first vector, we'll call that vector A, it'll have some size, but it also needs to be defined with a direction. Let's say that we either find that this is a 35-degree angle in here, or we actually measure that with our protractor. We need to know how to describe it. We just can't say 35 degrees. These are vector components. That means that they could be forces or accelerations or distances or displacements. And so we need to know 35 degrees where. So that's where the north, south, east, and west comes in. What you have to do is you have to think about the fact that this vector is in the first quadrant and it's opening up 35 degrees. This is the actual arrow. So it's opening up 35 degrees from the positive x-axis. Well, in direction world, that's east. And the way that it can open up is from the x-axis. It can either open up to the north or to the south. This particular arrow is opening up to the north. So the way that we address that is we call that 35 degrees, and then it's opened up north of east. This is where it would start, and this is how it opens up. This is where it starts, and this is where it opens up. Let's try another one. Okay. Let's say that that's 20 degrees. Okay, well, this is in the second quadrant. This is between north and west. This is the angle measurement. It's opening up from the west, so that's going to be the second direction. It's opening up 20 degrees, and it's opening up north of west. That's how these are done. Let's try another one. And say that's 30 degrees. You have to recognize this is in the third quadrant. This is west, this is south. So this is opening up in this direction. It's going to be 30 degrees west of south. You also have to be able to draw these. So let's say that we have some vector, and let's call it 10 newtons, and it's 40 degrees south of east. So now you have to do the opposite. I have a vector that's 10 newtons in length, whatever that's going to represent on my scale, and I have to draw it 40 degrees south of east. I need to remember east is where I'm going to start from. That's my second direction, and I'm going to open up 40 degrees south of it. 40 degrees. This vector right here represents 40 degrees south of east. That's how these are done. If you'll please do the practice worksheet that's attached on Schoology, that would be great.